Okay, today we're covering chapter 10-2, arithmetic sequences and series. So 10-1 was about identifying arithmetic and geometric sequences. This entire section is about arithmetic sequences, so they all have a common sum or difference. So the whole section, all sequences are arithmetic. These notes go right out of your book. So it's chapter 10-2. Please read your book to fully understand the section. It's page 666 to 668. So please use your textbook. So I'm going to just shorten up what you'll see in the book. The formula for an arithmetic sequence is given here. So this sequence is really helpful if you're asked to find like some number in a sequence. So I'll give you an example. Let's say we have a sequence 10, 13, 16, ... We can see that this is going up 3 and up 3. What if I asked you to find the 50th term? You don't want to have to count 3 50 times, so you use this formula. So the formula is a with a little baby n, that's a subscript n, a sub n equals a sub 1 plus n minus 1 times d. So it's really important that you understand n is the number you're asked to find. Number in the list. A1 is the first term. And then D, you should know, is the difference between the terms, the common difference. Can you see that? Yeah, perfect. Okay. So that formula is really important. In class, you would have to memorize it. It does show up every now and then on the SAT and the ACT, so it's good to know it and recognize it. The second thing we're going to do is look at what's called an arithmetic series. A series is when you add all the terms in a sequence together. You can read it right here. Formed when the terms of a sequence are added. So in the example I wrote up here, a series would be if instead of commas, we were to put in plus signs and we were to add the numbers together, the sum of a series. There's a formula to do this. If you're asked to find the sum of the first 50 terms in a sequence, you would use this formula to do that. Alright, let's get into some examples. Here it says find the 12th term of the arithmetic sequence. So if I'm looking to find a 12th term, I'm going to write A with a little 12. So in this example, n is 12 in our formula. This is the formula. So A12 equals A1 is the first term, so we'll put a 9 in here. 12 is n, it's the number we're trying to find, so we're going to do 12 minus 1 times d, the common difference. How much are these going up by? We have to calculate d. Looks like they're going up by 7. So D equals 7. So I'm going to put a 7 in here for D. Alright, once everything's plugged in, you just have to do the math. So A12 is 9 plus 11 times 7. That's 9 plus 77. So that's 86. The 12th term will be 86. Very good. Next example. Here, the information looks different, and that's what's tricky with sequences, is that problems can be presented so differently. So here we have the actual numbers in the sequence, and here they're telling you what A1 is, and they're telling you what D is, and they're telling you what N is. So this means they're looking for the 9th term in the sequence. The first term is -4, and they're going up 6. So we're going to use the formula. I do recommend that you write it down a lot. You should be really familiar with the formula. AN is the first term plus the number -1 times the common difference. So we're going to do A with a little 9. Oh, tricky. My A's and my 9's look just alike. A9 equals -4 plus 9 minus 1 times 6. So that's -4 plus 8 times 6. -4 plus 48 is going to be 44. Our 9th term, A sub 9, is 44. And the third type of problem, it says to find A sub 20. So that means that N is 20, and they're not telling you that, but know that the little number here, if it's not a 1, that's the value for N. So A20 is the first term plus 20 minus 1 times -8. $19 times 8, it's going to be what, 80 plus 72, -152. So 15 minus 152, -137. I'm going to write it with the subscript. This says the 20th term, A sub 20, is -137. All right, very good. So that's all one set of directions. That's just finding the nth term. Here in example 2, we want to write an equation for the nth term of the arithmetic sequence, which means we're going to do some work and we want to end in slope-intercept form. So this equation is going to look like y equals mx plus b, because if you remember, arithmetic sequences, they form straight lines, they're graphs, they model linear functions. So it's going to look a lot like the slope-intercept form of a linear equation. Let's take a look. Write an equation given the sequence. So I'm using the formula, but I'm not asked to find a certain number. So for these types of problems, n stays n. It's a lot different than our first example where we're asked to find the 12th term and we plug 12 in for n. Here, it doesn't ask you to find a certain term or a number in the list. It's asking you to write an equation. So n stays n. The directions say write an equation, n stays n. That's something that is very confusing. Okay. So A with a little n, no number, is 5 plus n minus 1 times, what's the common difference here? We're going from 5 to -13. So I'm going to say that's -18. Minus 18 every time. So D is -18. So now we have AN equals 5 plus, this is interesting, we're going to distribute backwards. -18 times -1 plus 18. AN equals, we're going to just combine like terms, this 5 and this 18. we'll write negative 18n plus 5 and 18 will make 23. And that's our answer. This is the equation that will create this sequence. So that's what we're looking for. If you look, this looks just like y equals mx plus b. The slope here is negative 18. And that's the common difference. A common difference is just like a slope, if you remember from the graphing last week. And 23 would actually be the y-intercept. So if there was a value before this 5, a 0 term, it would be 23. That's the y-intercept. Okay. Let's continue. Okay, so write an equation given the fifth term and the common difference. So this problem's different. We don't have the list. They told us that a sub 5 is 19, which means the fifth term is 19. And the common difference is 6. So some students will start at 19 and they'll subtract 6 until they get to the first term, because we need the first term. But I'm going to do it a little bit different. I'm going to use the formula and I'm just going to plug in everything I know to help me find the first term. I wish I didn't have to do this. It's going to confuse you. I'm actually not going to do it. I'm going to count backwards. Okay. So our fifth term, what's our first term? I don't know. What's our second term? What's our third term? What's our fourth term? Well, we know our fifth term. It's 19. And every time these are going up 6, so I'm going to think backwards. This would have been 13. This would have been 7. This would have been 1. And this would have been negative 5. So I can think about the pattern to help me find a sub 1. A sub 1 is negative 5. Now I can use the formula. Oh my goodness. Sorry. Okay. Alright. Let me switch to a pen. So our formula is going to be negative 5 plus n minus 1 times 6. And again, to rewrite this, you distribute backwards. Our nth term is going to be negative 5 plus 6n minus 6. We're going to combine the constants. 6n minus 11 is our equation for this sequence. And we weren't given a lot of information. We were just given the fifth term and the common difference, but this equation models the sequence that has this data. Okay, last one on this page. Here we have the first term. We can find the common difference. It looks like it's going down 9. So we have D is negative 9. So go to a red pen here. AN is 12 plus n minus 1 times negative 9. I'm going to distribute backwards. And see, I get AN is 12 minus 9n plus 9, because negative 9 times negative 1 would be a positive 9. AN is negative 9n plus 11. No, 21. All right, there's our sequence. All right, our last three examples are asking you to actually find the sum of a series. And the biggest difference between a sequence and a series is that here we see plus signs instead of commas. So you're actually adding all of the terms together when you find the sum of a series. So it's a totally different formula you work with. You will still need your formula for an arithmetic sequence a lot of times to get to the information here, but this is the series formula. So n is still the number you're trying to find, number in the list. So if you were trying to find the 50th term, you'd put a 50 there and a 50 there. A1 is your first term. A1 is the actual output for that number you're looking for in the list. So if you're trying to find the sum of the first 50 terms, you'd put a 50 here. And if the 50th term was 90, you'd put a 90 here. And then you always divide by 2, because really this is just like multiplying a number times an average. Okay, so find the sum of this sequence. So, one of the problems here is we don't know, because there's a dot, 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 we don't know what number this is in the sequence. So we don't know how many numbers it's asking us to add together. So we have to figure out which number in line 180 is. So to do that, I'm going to use the other formula. So I know I'm trying to find what number 180 is in this list. So I'm going to put 180 as the result. I'm going to put 12 in the first term spot. I don't know what number 180 is. I'm still going to use the -1, and I can see that it's going up 7, so I put a 7 here. I'm going to simplify. 180 is 12 plus 7n minus 7. 180 is 7n plus 5. I'm solving for n. $175 is 7n. Shouldn't be able to do this, but so we'll divide both sides by 7. Clearly, it's 25. So 25 is n. So now that we have 25, we're going to plug it into our series formula. So we want to find the sum of the first 25 terms. And that's going to be 25 times 12 plus 180 all over 2. And there we get it. The sum of the first 25 terms will be 2,400. Nailed it. Okay, let's do that again. Same situation. We need to find the sum of all of these, and we don't know how many there are. It goes all the way up to 100. So how many numbers are we adding together? We're going to plug in to the arithmetic sequence formula to figure out what number in line 100 is. So 100 is the first term plus We don't know. And what are these going up by 2s? So once you get comfortable with these sequences, a lot of this can be done mental math. And I know students who are really good with patterns just like to figure it out that way. So combining like terms, 2 minus 2 cancels out. And 50 equals n. And a lot of you probably just came to that conclusion realizing that this is going up by 2s all the way to 100. So now that we're looking for the sum of the first 50 terms in this sequence, I'm going to use the sum formula. The sum of the first 50 terms is going to be 50 times 2 plus 100 divided by 2. Of course, it's going to be 2,550. The sum of the first 50 terms is 2,550. Last one. All right, our third one for series is a little bit different. We're not given A1. So we're going to have to find it using the formulas, of course. Okay. So we're given n. That's handy. That's what we were looking for before. So n is 16. And then this says that our 16th term is 240. And our common difference is 8. But what is A1? It's always kind of a riddle of figuring out which piece of information is missing from the problem. So we're going to use our formula. AN is A1 plus n minus 1 times D. AN we're given is 240, says it right here. A1 is what we don't know. N is 16 as provided in the problem, and D is 8. So 240 is A1 plus 15 times 8. And so that's what 80 times 40. 80 plus 40 is 120. So 240 is A1 plus 120. Subtract 120. This is looking very symmetrical. And what do we have here? 120 is A1. Interesting. So the sum of our first 16 terms, we know n is 16, is going to be 16 times 120 plus 240 divided by 2. 16 times, is that 360? Divided by 2. 16 times 180. 2,880. So if we were going to add the first 16 terms up in this sequence, which we don't even have the list, our sum of that series would be 2,880. So kind of a lot here. Please read your book. The more you do it, the more sense it makes. You can please do the Quizlet that I've posted. That's going to help you become more familiar with the terms and the vocabulary. And then do the assignment on Schoology. Email me with any questions. Thank you.